Okay, we'll might make a quick sound check. Can everyone hear me okay?
Yep.
Okay, thanks.
Yep.
That's fine, thank you. So we're week 11 this week, which is file input and output. Thanks, Trent. File input and output. And it's our second last week. So last week was all on characters and string builder. And this week we're looking at file IO. So all about writing data to file, reading data from file. And assignment 2 is due at the end of this week. Okay. So we'll talk about that more in a second. Okay. Now, next week is the final week of term, and I was going to suggest that we work through past exams, but there's no exam this term because of the coronavirus. So the working through past exams isn't really needed unless you want to next week. So normally I say that we work through past exams. I'm not going to give you any solutions. It's all up to students to suggest parts of the answer, and we'll put it together. But no need to do any of that this term unless you want to. So next week I'll get you to work through any issues or questions or problems you have. And so please bring along your questions, issues, problems, and we'll work through any questions, issues, problems you have. Okay. Now I'm just looking in the chat window here. So someone's asked me a question, and I'll post it to the window because it's a question probably everyone's got. Okay, I'm not going to mention any names because he sent it to me privately. But if you could just type a yes or a no in a window, if you're happy for me to post your question, I'm not going to mention your name, and just say yes or no because it's a question I think everybody's got. Okay, thanks. So here's a question here. I think it's a good question. So I'm really struggling with the Java programming assignment. I want to see if you'll be able to spare 15 minutes of your time after the lecture today to ask a few questions and get some advice. This is my last assessment piece, and due to this being my first time ever doing coding, I'm incredibly stuck and have no idea what's wrong or how to fix it. I've tried to rewatch your lectures and textbooks to no avail. Okay, I understand that. That's a fair point. So what we might do in this week's tutorials, which is Friday, we'll look at some aspects around the assignment. And I can't help you directly with your assignments, but I can help you with problems that are like the assignment. So instead of an array of pizzas, I could do an array of dogs, okay? Or maybe an array list of dogs. I can't do something that's identical, but I can do something that's similar. So if we maybe look at that array list of dogs question again, and then it'll get you thinking about how to work with pizzas. Okay, we've got another question there as well. About the assignment, what should be the maximum number of pizzas a customer can order? I think they can order any amount. Okay, I think your array size at the start's 10. So as long as they have an order, as long as you don't have 10 pizza orders, I think you're good to go. So I think it's 10.
So does it have to be 10 or less, or can a customer actually order more than 10 pizzas? Like,
okay, they only order one at a time.
Mm-hmm.
So every time you click the add order button or whatever, it just adds one order to the array.
Okay, I was asking this question because the assignment sheet actually was asking asking me to set the maximum number of pizzas that customers can order, and I wasn't really sure what the maximum number has to be.
Okay, righto. We'll go through this on the spec again in a little while, and we'll also look at some aspects of the assignment question to try and help things fall into place for you. Okay.
Okay.
So I think the problem people have got is how to create a pizza, how to add it to the array, how to check if there's space in the way or room if there is still room in the array. I'm thinking they're probably the main questions people have got just by reading through the lines here. Okay, so we'll go through the lecture material, and we'll hopefully finish up within an hour, and then we'll get stuck into looking through some assignment 2 stuff. Okay. If we're in class together, this would be so much easier.
Well, unfortunately I forgot everything related to the Java GUI bit, so that's being a big problem to
Oh,
me.
all right. Yeah.
Okay.
Okay. Righto. Um, so let's press on with file IO, and then we'll come back and we'll round on back as soon as we can to talk about the assignment. And then through this week's tutorial, we'll also talk about the assignment. So we've got Friday morning or Friday around lunchtime for 2 hours to talk through the assignment as well, and work on aspects that are like the assignment, but not. I can't work on the assignment directly, of course. So and the due date for the assignment is Friday at midnight. But again, I'm happy to do what we did for last assignment. I'm happy as long as you submit by Sunday night. Before Monday at 9 o'clock, say, I'm not going to take any marks off anybody for lateness. Okay, so, and I think Bruce would support that as well. So, okay. Oh, and we'll also talk a little bit about the exam. So instead of an exam, you've got an assignment-based problem coming up. Okay, and you can say you should check Bruce's email. It's the 22nd of May at 3:39 p.m. He sent through the email on the alternative assessment. Okay, I'm not sure how you submit it. I think he's probably going to add a link to the course webpage to submit the alternative assessment. But just keep an eye on your email, and Bruce will let you know. And if you've got any questions about anything on this, ask it in the course forums, because there's probably other students with the same questions, and Bruce will get right on it and answer your questions and take care of everything. Okay, so he's a really good guy. He's over his keyboard like this, ready to answer questions. So he's a really good guy. Okay, so we're here in week 11, file input and output. So let's proceed with that, and we'll try and double back. So file input and output. So we're going to learn about computer files. We're going to use the path and the files classes. Learn about organization, streams, buffers. There's a whole bunch of classes in Java to do with reading and writing data from something. So there's many ways to read and write files in Java, and we'll just look at a few ways. Okay, so my advice is that find a way you like best to read and write a file, and just stick with that for this stage, at this stage. So through this course and a following course, you can just use one way to read a file and one way to write a file. Okay, so there's many ways to do it. It's going to probably make your head spin. There's so many ways. I know at least 5 different ways to read and write files in Java. So there's so many ways to do it. We'll look at sequential files, and then we'll look at random access files, just quickly. And we'll write some records to a random access file and read records from it. Okay, so computers generally use volatile storage. Computer memory or random access memory is RAM, and it's temporary still. They have tried to change that. They have tried to make it so it's flash RAM in your computer main memory, and they're hoping to get flash RAM quick enough. And gee, they're working on it like crazy, but they've never quite got there. They've been trying to do it for 20 years or more. And so that when you turn your computer off, the flash RAM contents are still there. But at the moment, RAM's still volatile. Might change one day. Okay, unless you're using general purpose computers. Special purpose computers, they've got flash RAM. But general purpose computers, PCs, laptops are still using volatile random access memory. And that's when the power's lost, when you turn the power off, pull the battery out, the memory's gone. What was in the memory is gone. So non-volatile storage, on the other hand, is when the computer loses power, the contents are still there, the contents of the memory is still there. And like I say, they've been working on it for over 20 years to try and make flash RAM or some sort of non-volatile RAM to be part of the computer's random access memory, but it's never come in. They've been trying. Dynamic RAM or static, it's this, the little RAM chips are going increasing in storage too quickly for the flash RAM people to catch up, but they're getting there. I think they're probably there now. Then it's down to speed. A computer file is information stored on a non-volatile device in a system. Computer file. So you've got permanent storage devices like hard disks, zip disks. Nobody uses those anymore, unfortunately. USB thumb drives. You've got reels or cassette magnetic tape, and still used on servers and mainframes, magnetic tape. It's huge storage capacity, but it is generally a little bit slower, and it's also sequential access. To get to the 10th file on the tape, you've got to fast forward or rewind the tape to get to that file. Compact discs, DVDs, that sort of stuff, they're all permanent storage devices. Categories of files, there's only two types of files really. There's text files and there's binary files. So text files are files we can understand. For example, in my notes here is a text file. If I'd written data to a file that was like 415, 4th of May, 1994, or 5 or whatever, etc. And that was a data file, that would still be a text file because it makes perfect sense to me. It's got my name, it's got my employee ID, it's got my start date. Okay, so that's still a text file. So text files are things you can make sense of without having to decode them and decipher them. Everything else is binary file. So binary files, so you can give some examples of binary files. Any examples? So you got video, you got pictures or images, pictures, you got sounds, you've got icons, okay, as well as things like executable files. Your java.class file is really, well, that would even be in a halfway house, the .class file, because you can understand parts of it without decoding it. But I'll put that in a binary file for now. I won't split hairs. Class files, your jar file that you can create from your Java class files. Things like zip files. So basically anything that's not a plain text file or a text file is a binary file. So the vast majority of files are binary files. Okay, data files contain facts or figures, usually something to do with an application. It might be the settings for an application. It might be the last used settings that the user had when they exited the program. Or it could be actual data files to feed data into the program. Lists of facts and figures, prices by date or whatever, product prices. Program files or application files store software instructions. So these are the binary files, the executables, those sort of things, the program files or application files. Then you have things like root directory, that's the root of the drive that you're currently using or a drive that can be used. For example, the C drive's got a root directory. On Unix, it's just that or the base of all folders. And then you've got folders and directories below that. Both are the same thing. Some people call them folders, some people call them directories. Some people mix and match names. They're both the same thing. So a path is a complete list of the drive plus the hierarchy of directories in which a file resides. So that there might be a path. Okay. When you work with stored files in an application, you perform the following tasks. You determine whether and where a path or a file exists. And if it doesn't exist, you can't really do much. Maybe you could create the path if it doesn't exist already. If the file doesn't exist, maybe you could create the file. then you open a file, maybe you read data from it, close the file, and then when you're doing something later, you might open a file, write data to it, and then close it again. And you might delete a file if you want to recreate something. So these are sort of common tasks. And the one I suggest that's missing is you might also want to create a path if it doesn't exist. That's another common one. But reading files, writing files, creating files, all that sort of stuff's pretty common. So there's a whole bunch of classes in Java to work with files and file paths. One's the path class, and that's used to create objects that contain information about files or directories. Okay, so if you want to get information about a file or directory, is something a file, is it a directory, all that sort of stuff, you use the path class. Then you can use the files class to perform operations on files or directories. Okay, and there's the java.nio, new IO, nio.file package. And that includes both path and file classes. Okay, so you do an import for that, java.nio.file. So first determine the default system on the host computer. Okay, so file system fs equals file systems.getDefault. And you can use that to work with files and paths the correct way for the current host operating system. So if it's Linux, you'll get the Linux slashes in there. If it's a Windows, you get the backslashes in there and all that sort of stuff. So it takes care of all that. Then you can get a path. Okay, so remember the slash character in Java is an escape character. So we use /n to get a new line. We use /t to get a tab and so on. If you want to put a slash in an output string or in a string, you've got to go / to get the string to appear. C:// Java / chapter 13 / data.txt. So that's really a path that just says that's really what the file would look like there. Okay, so the / is just to get the string to be, to get the single slash to appear in a string properly. Now Java's really forgiving because it's made to work on multi-platforms, the Java virtual machine. If you coded your file path like this with the wrong slashes, Java wouldn't care. It would still open the file. Okay, so that would work even on Windows. So either of those would work. So Java is really forgiving. It does take care of a lot of stuff for us, and it's one of the things it takes care of. So every path of these are absolute or relative. So let's say you're working in a folder and you say, give me the file that's in data, abc.txt or dat, whatever. You want to open that file. Okay, so that's a relative path. That means in the current folder where you're currently working, look in the data subfolder and get the file abc.txt or abc.dat. Okay, so that's a relative path. This is an absolute path. These are both absolute paths. You're providing the file, the folder, the drive, and the complete location to the file and where it lives and its name. Okay, so relative and absolute. Relative paths are where you're currently working or where the current folder currently is set. And absolute paths, doesn't matter where you're working, it'll find the data in that location. So retrieving information about a path, there's the get file name, and that returns the file or directory denoted by this path. And get name count returns the number of name elements in the path. Okay, we'll talk about this more a bit later. And there's a get name that returns the name of the position of the path specified by the integer parameter. Okay, so if you've got 5 parts for name, you can go through and get 0 to 4 out of it to pull the path to pieces, in other words. So you get the parts of the path. Those methods available there if you need them. There's plenty of others. So let's have a look at that. So that's our file we're going to try and look up. And path is file.toString. File is filePath.getFileName. So we're getting the file name to get the file name. File path.toString gives us a whole path. So it'd be C:\Java\chapter13 /data.txt. Get file name will just give us data.txt. And there are 1, 2, 3 elements. Depends whether it counts the C drive as an element. There could be 4. So that's something for you to check. And then you can display each part of the path if you want to. Is that counted as part of the path? Okay, so that's something for you to check later. Using scanners, we're getting the name of a file from the user. They can type in the name and paths.get, and then we're converting our string to a paths object. Path full path equals input path.toAbsolutePath. So if the user typed in something like this, data abc.txt, then toAbsolutePath would convert that to maybe something like that, depending on where that file lived in the hierarchy of files and folders. So toAbsolutePath would fill in the whole thing. Okay. And then you can display it to the screen with full path.toString. Okay. Now, if the user keyed in that whole thing, which is already an absolute path, then full path is full path toString, wouldn't change anything. It would be just what the user typed in. It would probably have the slashes fixed up because it knows it's on a Windows file system, so it would fix the slashes for you. Okay. Not that Java cares about that sort of thing. Okay, so you can also check whether a file is executable or readable or writable, or there's a whole lot of stuff you can check with files. You can check their attributes to check whether the security attributes on a file. You can check the file modified dates and times, all that sort of stuff. Anything you need to do with a file, just about, you can do with Java. So here we've got a file that we're looking at, and it's our class file, our compiled bytecode Java code. And then we're checking the access of the file to see whether it's readable and executable. Okay, and then it displays file can be read or executed. Okay, now this check access, if the file wasn't read and executable, then it would come down here and throw the exception. And we'd see that the file cannot be used for this application. Okay, so we haven't officially covered try-catch there, but we are doing a bit of it this week. We did talk about it briefly in a prior week. Okay, so any of the code that might raise the exceptions here in the try block, and then in the catch block, we're dealing with the exception, which is just displaying a message to the screen at this stage. Okay, so file path, it's quite a mouthful. File path, get file system, because we want to check whether we're checking the attributes for the right file system. .provider, .check access, we're checking our file path object, which is our path, and check whether we can read and execute that file. And if we can, that message will appear. There's other ways to do it. Like with everything in Java, there's other ways to do it, but that's one way. Are there any questions on that so far? I know we haven't officially done exception handling yet, so don't let that worry you. No questions on that? Okay. We've got eight people with us. That's good. 8 people. Okay, so here we're trying to delete a file. So we're converting a file string to a path object. And then we're saying files.delete that file path object. Okay. And if that command succeeds, then we've got that message will appear on the screen. File or directory is deleted or was deleted. If an exception's raised, then we've got a whole bunch of exceptions that could occur. So we're catching each exception type so that we can raise an error message, the right error message to the user. Okay, so if it's exception type this one, we can say there's no such file or directory. If that's the exception type, the directory is not empty. So we're trying to delete a directory. In this case, it's just a file, but we could be trying to delete a directory and the directory is not empty. So you can't delete it, can't delete a non-empty directory. If it's a security exception, then we don't have permission to delete whatever it was. Otherwise, if it's some sort of exception, we don't know what it is. All we can say is some error occurred. Okay, maybe we can probe more deeply, but that's all we're going to do for this example. Okay, so this is sort of exception handling, taking it to the next level. So for each try block, you can have multiple catches. And the reason for that is that so you can handle each one differently. You could just have catch IO exception at the end and take all those others out and just say some sort of error occurred. I don't know what it was. Okay. But by having the granular catching different types of exceptions, you can display more informative error messages or handle things differently. Okay. So no such file. You can say there wasn't any file that I could delete. It doesn't exist. If there's directory not empty, I can say the directory is not empty, so I can't delete the folder. If there's a security exception, I can say no permission to delete the file. You don't have security permissions. Okay. Otherwise, when you get up to this level, a high level IO exception, all you can really say is some error occurred. I don't know what it was. Okay. So all of these other catches give you the granularity to display a meaningful error to the user, rather than just a I don't know what went wrong error. Okay, but this is all out of scope really for this course. We haven't really done try catch, haven't done exception handling. It's just talking about the bare minimum, just so you can start to understand this code. If you want to get the attributes, for example, the creation time or the last modified date and time, here's one way to do it. This is probably the best way to do it. So you get a path object again called file path from your string. And then you get a basic file attributes object. I'll call it attra there. Files.read attributes. You pass in your path object. Basic file attributes.class. Okay. So we're saying .class there. And then once you've done that, you can get the creation date time and the modified date time and the size of the file in bytes and a whole bunch of other stuff. Okay, so there's a whole lot of stuff you can get about a file. So basic file attributes and the path object are the basic ways here. Basic file attributes objects. Okay, any questions on anything so far? So how do you know? Okay, we're not going to officially cover exception handling, but how do you know what exceptions code might raise? And well, you just write it. You can look in the help for it. For example, let's have a look in the help for that one. Basic file attributes. code was files read attributes. So we need a files app object to read attributes. Often it will tell you down here what exceptions are raised. And but we're also using a files object to read attributes. So files, read attributes. Read attributes, there it is. And there's the exceptions. So unsupported operation exception or an IO exception. Unsupported operation. So we could have two catches there. We could have a catch for unsupported operation, but the parent of all exceptions in that part of the tree anyway is IO exception. So if you just catch IO exception, then you're catching all the children as well. Okay, but you could have a catch there for each one. You could have a catch for unsupported operation exception, and also a catch, and a catch for security exception as well. So you could have 3 catches there if you wanted to. Okay, but in this branch of the tree, IO exception is a catch-all that catches all of those children exceptions. There's a whole hierarchy of exceptions in the exception tree, more than we're going to talk about. Okay, so you could have multiple catches, or you could just have one catch to catch the highest level exception. And if you're not sure what the highest level exception is, just leave out the try and the catch, and try and compile this code. And Java will tell you very quickly that this code here can raise this exception. You need to handle it. Okay, so it'll tell you it's a compiler error when you compile your code. Okay, so that's probably enough for paths for now. So a bit on file organization, and we'll talk about strings and buffers as well. So when you retain or need to retain data for any significant amount of time, you need to save it on permanent secondary or on permanent primary or secondary storage. Businesses store data in a hierarchy. So you can have multiple characters making up a field. For example, multiple characters making up a name, multiple characters making up your start date, all that sort of stuff. So you've got the characters make up fields. Multiple fields make up a record. So each employee might have their own record. For example, Mike had his own record up here. That was characters. Name was a field. That was a field. That was a field. So 3 fields so far. The whole thing's a record. And then multiple records make up a file. Okay. And sequential access, each record is stored in the order based on some field. Okay, so maybe we're writing data to file in employee ID order. Maybe we're writing data to file to alphabetical order. Okay, but sequential access, if we've written it in that order and we want to read it back in, it comes back in that order as well. Okay, so what you write it out in comes back in as well in that same order. So there's an employee file. You've got the Andrews record, the Brown record, the Collins record, and so on. Many records maybe. Here's just the fields for the Brown record. So it's an ID of 786, Brown, Jennifer, 12.95. That might be the hourly rate, first name, last name, employee ID. And then each one of these fields is made up of characters like Brown, so on. Are there any questions on that? Is that okay? Okay. Okay, so how you work with files? You need to open a file. So you create some sort of file object or stream object that can get a handle on the file. And then you associate a stream of bytes or some sort of reader to help you read the file in. Then you're going to read the file, and then later on you're going to close the file. So make sure it's no longer available to your application. So every file you open, you should close, because if you exit your program without closing a file, you do run the risk of maybe some data corruption happening. Files being left open, handles and files still existing. So if you try and move them from another application or read from another application, it could be locked. All that sort of stuff can happen. So open a file, and when you're finished with it, close it. A stream is a stream of bytes that flow into your program from an input device, or bytes that flow out of your application to an output device. So you've got input streams and you've got output streams. Most streams only flow in one direction, so you've got an input stream or an output stream. But of course, you can have input and output streams that flow both ways. But most streams only flow in one direction. So you can open a file for reading, you can open a file for writing, or you can open it for reading and writing as well. So you can read it and write it all at the same time. So for reading a file, you might have input data coming out from a file, in from a file or whatever, into your application and then getting written out again later on to an output file. And they could be the same file. This input file and the output file could be the same file, or they could be different files. Depends on what you're trying to do. A buffer is a memory location where bytes are held after they logically input or output, before they are sent to the output device or as they're being read from the input device. So buffers can be for input as well. And it's the whole idea of a buffer is to make something faster. So disks tend to be relatively slow or slow compared to speed of memory and speed of CPUs. So buffers are used in memory so that the CPU doesn't have to wait for the disk to spin or the file to get written to for the data to get written to a file. Okay, so that's a buffer. So it's an area of memory where you're holding data while it's being written to file or while it's being read from files to speed up the operations. So your CPU is not sitting there twiddling its thumbs waiting for data. It's to help speed things up. And they do speed things up enormously. Flushing is the act of clearing a buffer. So when you're writing a data to a file, you want to flush the buffer to make sure all the output's sent to the file and then close the file. Okay. Now, Java does mostly take care of that for you, flushing. So you can just close the file and everything's good. Okay. For what we're doing anyway, that's fine. Okay. So we've got a bunch of classes in Java. And there's many ways to do it. Like I said, there's at least 5 or 6 ways to read files in Java and 5 or 6 ways to write files. I'm going to show you 2 ways coming up. Just pick the way you like the best and stick with that. I wish they had the old scanner slides in. We're using scanner to help us read files. And but those ones were removed, unfortunately. Because that tends to be the way people like best. But anyway. So at input streams, output streams, readers, and you can combine all these things together to create ways to read and write files. Well, maybe not readers for writing files, but there's other objects for other classes for writing files. So system.out is one way you can send data to a stream. And system.error is usually reserved for error messages. And system.error messages usually go to the console screen. Okay, so for example, system.out, even print line can be redirected. System.error. Error can be redirected as well, but usually it's not. But you can run your Java program like this. So you can run your Java program with a pipe symbol. This is assuming using a DOS command line. So we're piping the output from hello to out.txt. So if this hello world program contained those 2 statements, this one would send the hello text to the out.txt file. And this one, the hello would still appear on screen. Okay, you can redirect error as well, but generally people don't do that. But just simple piping or redirecting from the command line, generally only for what we're doing at this stage, it's only for the output device, that device. Okay, so not a bad thing to do if you're producing errors is to make them so they're system.error.println, and that way you're sure they definitely appear in the would be the output from the program. Hello would be in the file. So if you're using system.error to print error messages at the console screen, then it's much harder for it to be redirected to an output file. Still can be. So system out, system error. I don't think we've thought about system error yet. Okay, so you got part of the hierarchy for some of the ways to read files and write files. You've got input streams, file input streams, buffered input streams, filter input streams. And then for the output streams, you've got file output stream, filter output stream, buffered output stream, print streams. And then for the reader class, you've got buffered reader, buffered writer. And you can combine buffered readers with file input streams to read a file with a buffer. You can combine file output streams with buffered writers to get a buffer when you're writing data to a file to speed things up. Okay, so generally around these classes here, you put a buffer. Like those two, they work really well. So there's an input stream. It's an abstract class. We won't talk about what abstract classes are, but so you'll use file input stream and buffered input stream when you're reading files, for example, for one of the ways to do it anyway. And output stream and file output stream and a buffered output stream. So you use those two classes there to work with when you're writing data to file. Okay, for one of the ways anyway. There's many ways to do it. And then you might use buffered readers and buffered writers around those to make things much faster. And even with modern SSDs, when you've got gigabytes a second write speed and read speed, these can still help speed things up. Okay, we won't talk about those too much. Let's just look at it in practice. Okay, let's get some practice code coming. So when you write to a file, one of the ways is to assign a file to an output stream, construct a buffered output stream around that, and assign it to the output stream. And then you can create a writable file using the path class, and so on. Okay, so it looks pretty complicated. And it probably will look complicated the first few times you do it. So there's writing or appending files. You can truncate existing if you want to, create new or create. Create new only creates the file new if it doesn't exist already. Otherwise, it throws an exception if it already exists. You can delete on close if you want to. You can set all these sort of parameters up in your file operations. So how you want to open a file, what you want to happen at the end. You can make it delete on close so that the file automatically deletes. So if it's a temporary file you don't want to keep, just make it delete on close. Okay, and that's on the close of the program, not the close of the file. Okay, so great for temporary files, I think. Okay, so let's get some data out to a file. So we're creating a path object called file, paths.get, C:\Java, chapter 13, grades.txt. That's the file we're going to write to. There's our data, string A, B, C, D, F, no E. So just a string of data. We're converting that data to a byte array, byte square brackets data, so an array of byte, which is like a char. And we go, whatever our string is, it's s.get bytes. So that's converted that string to an array of bytes, which are like little integers. And then we're creating an output stream object, output stream output equals null. So none of this code so far can raise an exception. So that's why there's no try. That's not inside the try. It could be in a try, it wouldn't matter. But it doesn't need to be in a try because none of this can raise an exception so far. Okay. So here's the code that can raise the exceptions. So that especially has to go inside the try block. So output equals new buffered output stream. So we're using a buffered output stream. Files.new output stream. We're passing through our file object. which is this chap up here. And we're saying create the file. So if it exists already, we're going to override it. Okay. And then we're going output.write. And then our data was our byte array. Output.write data. And then output.flush to ensure the buffer's flushed. And then output.close. Okay, so you can see we're doing operations for our output stream object. Whatever that guy there is, output. Output stream, it's output equals new, output.write, output.flush, output.close. Now there's a whole lot of exceptions this could raise. I could show you in the Java help for buffered output stream and the file's new output stream method. There's a whole lot of exceptions that this could raise, but the parent of them all, the top of the tree, is exception. So this code here is saying I'm not going to generate a message for each one. So could not create the file for output, could not write to the file, a disk error occurred, a security error occurred, all that sort of stuff. I'm just going to say whatever the, I'm just going to say message followed by E, which is our exception object, which is going to give you the first line of the error message that's generated when you do a stack trace. So it'll say whatever, file could not be created or something like that, with a whole bunch of Java stuff around it. So not a nice error message for users to see, but perfect for us as programmers. That's okay. Another good thing to add there, I would add e.print stack trace. I would also add that into the catch so that it printed out the whole stack trace. So you can see all the parts of the error and the hierarchy of what was being called. And that can really help you work out where the error is as well. So whatever that object there is, you can say E on its own to get part of the error message. That's the first line usually, and e.print stack trace to get the whole thing. Okay, so that's one way to write a file. So if you had a lot of data in an array and you were trying to write a file, maybe you could move this code down here into here and put it in a loop. And for each part of the data in the array, convert it into a string and go string.get s bytes and put that in the data bytes array, and then write that data out to file. So you do a loop around this part here, getting the data out of the array, putting it into the byte array, and then writing it to file. Okay. And you might want to put a /n after a slash new line after it to make sure that you've got one record per line, maybe, depending on what you're trying to do. Okay, so if you want to write your pizzas out to file, or your dog's data out to file, or your employees, the code is pretty complete. All you need to do is add a loop, for example, like this: for int k is equal to 0, k is less than, I'm assuming they're in an array list, emps array list size k plus plus. We want to get that data byte data equals emps array dot get k dot to string and output data. So if you put that for loop there in to replace that single write statement, output.write, output, then that would write all the data in your array list at the file. Okay, so expanding that to work for an array list or an array is really easy. Then at the end you would go output.flush. You might want to put a new line there as well, maybe +/n to get one record per line. Okay, flush, and then output.close. That's sort of how your code would look there to do the whole file. Output equals new. Okay. And you could even say message at the end here, system.out.println. It'd be whatever your file name is. Just output a message to the user on the console screen, just so you can keep track of what's being written or read. That's always a good thing to do. Okay, is that okay for writing data to a file, writing data from an array to a file or an array list to a file? Just loop through the array, get each line of data or each record of data, convert it to a string, add a /n on if you want to. You'll probably do it at this stage. So you can look at your file and see it in text editor and it's not all one big line. And then output.write. Just keep doing that in a loop. Okay, any questions on that one? It's all okay. Okay, cool. So output streams are for writing data to file. Input streams are for reading data from file. So it's input stream and new input stream. So we're going to look at the same sort of code we just had, but instead of output stream and now it's going to be input stream. Okay, and we're going to read the file back in to something. Okay. So a path object again called file, link to our file, input stream, input equals null, input equals files.new input stream file. Okay, so when we're writing the file, go back 2 slides, we said new output stream, and then we told what we wanted to do with it, create the file. We could say append, all that sort of stuff. We could say all these flags, but for inputting a file, we're just going to read it. So we don't have all these flags to control here. So it's just input whatever our file is. It's our file object, input stream object. So we're putting a buffer around our stream to make it more efficient. String s equals null, s equals reader. So reader is our buffered reader, which is wrapped around our input stream. S equals reader.readLine. So we're reading a line of data from the file. Okay, so it's up to and including the /n. And then we're printing it to the screen. And then we're closing the file, input.close. So we're not writing data to a file here, so there's no need to flush it. So it's just input.close. So it's just reading one line of data from a file. Okay, if you want to read multiple lines of data from a file, much the same code, try, catch, input equals buffered reader. Okay, so the trick is with reading an array of data from a file, How do you know how many to read? Okay, so you can keep reading until there's no more data in the file. Okay, so you've got options. Data. Or the other option is to, when you write the file, write out the number of records as the first line. There's really two options there. You can keep reading until you've got no more data until you get to end the file, or else when you write the file, you can write the number of records count as the first line of the file. And then when you read that file back in, read the count first, get the count in, convert it to an integer.parseInt, and then use that to control your loop. So there's various options there. And that's why scanner was so good when you're reading files, because you can say your scanner object .hasNext. You can use the .hasNext method to see if there's any more data in a file. You can do that as well with streams and things, but we're used to working with scanner. We've been using it all term. Okay, so let's read an array of data. That's the basic process. Of course, if your array list contains employees, you want to convert that to not text, but you want to convert that to employees. Okay. Maybe you want to add the employee to the array. So maybe you want to do something with that string. Maybe you want to use the split command that we looked at last week, string.split. It might be coming in tab separated or space separated or comma separated. So maybe the split command will help you. And then you get the data and convert it to an employee, and then add it to your array list then. Okay, so depends on how your data's coming in and what it looks like. So there's a whole bunch of methods you can use. You can read and close, of course, and then you can read from a certain offset, read a portion of a buffer, or read a portion of array. You can read a line of text if you want to, or you can read part of a line of text. You can skip so many characters if you want to skip. Whatever. Of course, you've got to be careful with these commands. Read and offsets and skip, because you don't know how many characters you want to skip. You want to be careful not skip halfway through the next record and start reading from that as like it's a new record. So be careful. Buffered writer is a counterpart to buffered reader, and it writes text to an output stream. So that's one way to read a file, one way to write a file, and one way to read a file. And if you're happy with those, that's fine. But there's another method in the slides here that I'll show you quickly because it's in the slides. And so buffered writer class is another way to do it. And that writes text to an output stream, buffering the characters. The text has 3 overloaded write methods that can provide for efficient writing of characters, arrays, and strings respectively. So there's three write methods that you can use for buffered writer. Okay, so let's look at buffered writer. So again, we've got a path object called file. We're creating an output stream new, buffered output stream, files.new output stream, file.create. So we've seen this sort of code before in our prior example. Buffered writer equals new buffered writer, new output stream writer output. So putting a buffered writer around our output stream to make it more efficient. Okay, so our CPU is not sitting there twiddling its thumbs waiting for the data to go out to disk. Even on SSDs, the CPU is waiting a long time for the data to go to a disk. It's waiting an eternity. Okay, even though SSDs are so fast. We're getting a line of text from the user, and if they enter quit, we're going to quit. Otherwise, get the name of the employee, name equals input next line, enter their pay rate equals input.next double. We're concatenating all the data together into a string, so ID plus delimiter plus name plus delimiter plus pay rate, and the delimiter is set to comma. So it's comma separated data. So we've got to hope and pray that when they enter a name, they don't enter something with a comma in it, because that'll throw off our file completely. We have to do something else, a better way than comma. Maybe tab would be safer. Okay. And then writer.newline. So we're writing out a new line to our file. And before we do that, we're writing out the data. So writer.write. This is our string we've just concatenated. So we're writing out 0 to the string length. So we're writing out all the characters in the string. And then we're writing out a new line as well, just to put, so it's one record per line. We could also just put a /n here if we wanted to. Put a plus /n, then we wouldn't have to worry about writer.newline. That would be fine. Then enter the next ID or queue to quit. So keep looping as long as the user doesn't enter to quit. So if the user wants to type in 20 records, they can type in 20. If they want to type in 5 records, they can type in 5 and then type quit. Okay. So output's our output stream. We're wrapping that up in a buffered writer to make it more efficient. And so it's writer.write, writer.newline, writer.close. You might notice as well here we didn't have to do a flush. With buffered writers, you don't have to flush. So how do you know whether you have to flush or not? Well, you look at the help for the method. You look at the help for the class and see if you need to do a flush there. It'll tell you in the class. If we have a look at buffered writer, it will tell us. Before you close a file, you've got to flush the data. So, whatever. So that's another way to write a file if you like that way better. Okay. It's a little bit more complicated example here because I've got a looping through getting records from an employee or records from the user. But the actual mechanism to set up the writing is no harder than a prior example. Any questions on that so far? Any questions on anything so far? Okay. So this is a method you might like to use with buffered writer. So you can see the close method here closes a stream, flushing it first. So that's why there's just a close, not flush as well. No need to flush it because the close does it automatically. Okay. If you're writing files and it was taking hours to write the data to file, you're writing so much data, gigabytes of data to file, and it was taking hours, maybe you want to do a flush every 10 minutes or something so you can at least keep that much data. Maybe a flush every minute. So that if you lose power or lose whatever, you've at least got that much data written to file. So you can flush often and close once, maybe. Same sort of thing with input streams. So we've got input stream object that's linking to our file. That's our path object up here, file, new input stream. We're wrapping that in a reader to make it more efficient. And then we're saying reader.readline. And while S, the string that's read in, is not equal to null, then we got more data, so we can read the next line. So reading the data in under loop. So this is sort of part of what we're talking about here. How do you know how long to loop? This is doing it for us here. While S is not equal to null, while the readline method doesn't return null, we've got data to read, so we can keep reading. Okay. So if we do this, let's just change this slightly. That'd be the sort of thing to read if you don't know how many records are in the file. Read a record. If it's not equal to null, split it up, convert it to whatever commas to fields. Use those fields to build an employee object, add them to your array, and then read the next record from the file. And if that's not null, you'll do the split again. Use those fields to build a record, add the record to the array. Build an employee anyway. Okay. Any questions on that one or the prior one? So buffered reader, buffered writer. We're just adding buffers around our reader and writer classes, just make it more efficient. Okay, so if you, even on the latest SSDs, it makes a huge improvement. If you're writing a lot of data, if you're writing a few bytes, it doesn't make any difference at all, really. But if you're writing a lot of data, it makes a huge difference. Or reading a lot of data. Okay, so sequential access files are access records sequentially from beginning to end. They're good for batch processing the same task with many records one after the other. They're inefficient for many applications. Okay, so sequential access files, you might, if you've got 1,000 records, you write them in whatever order you want. They might be random order, they might be the order of employee name, they might be order of employee ID. You write it out to file. But if you've got to get to the 55th record, or the one for employee ID 567, you've got to read through all the records till you find a match. Okay, so it's like the sequential search versus a binary search we talked about earlier in an earlier week. Okay, remember the binary search, it relied on data being sorted, and it jumped to the middle of the data and compared what you're searching for to what that middle location said. And if it was more or less, it went to the first half of the second half of the array, chop that in two, and it converged super quickly. Same thing with files, sequential access files. You can read them into an array and search them sequentially, and that's still a sequential search. So if you've got 1 million records, it might take you a few seconds to search through the file or the array. And if you've got 2 million records, you'll double the time. Okay, but you can do something like we did with with binary searches. You can do that with files as well. So you don't have to store everything in an array. Okay, so they're good for batch processing. In other words, when you want to process all the records in the file, sequential files are great. If you've got to find a particular file and display it to the user, it can take time for the user to see that record. Okay. If you've got 1 million records, you've got to search for 1 million employees. Even if their data is stored in an array, it can still take time for the employee to be found. Okay, so if you've got a real-time application there where the user requires immediate access or sub-second access, maybe sequential files and sequential arrays and sequential searches are the right way. So one thing you could do is load it into an array, sort it in the order the user wants, in other words, how they want to access it, and then you could use a binary search to find the employee. That would be super fast. But what if the data's changing a lot? So other users are changing it all the time, and you can't read the file and sort it and let the user search it 50 times a second. So whatever, so every second. So because the data's already out of date by the time you've read it. So maybe there's other ways. So that's where random access files comes in. So if it's just one user, maybe you can load all the data into the array and sort it and process it really efficiently. But if it's a multi-user system where multiple people are writing to the file or reading to the file all at the same time, loading it into an array, sorting it, and letting the user search it's not an option because the data's already out of date. Okay, or it could be out of date by the time you display the results. That's where random access files comes in. So records can be located in any order, and they're also called direct access files or instant access files, so random access files. Okay, and you create a file channel object, and that's an avenue for reading and writing a file. You can search for a specific file location, and the operations read or write can start at any location in the file. One of the methods we're going to use is the byte buffer wrap method, and that encompasses an array of bytes into a buffer. Okay, so random access files. For what we're doing anyway, they work a little bit like this. So okay, so let's say you've got an employee with ID number 1. They might be stored at the first line of the file, or the start of the file maybe. Okay, and let's say you've got employee 10 or employee 15. Okay, there might be a gap of there'll be a gap there of 14 records before you get to record 15. Okay, and let's say you got employee number 99. So you can see what's happening here. You're going to end up with a file that's got their space reserved for 99 employees or whatever, but maybe we're only using 3 locations in the file. So it's like a big sparse file, if you think about it that way. And if we had employee number 9,899, then they would be way down the file somewhere. There'd be a huge gap between them and them. So if you loaded the file and dragged it onto a text pad or whatever, you'd find that record pretty quick, and you'd be scrolling down a long way to find that one. It'd be way down the file. So space is still allocated for employees based on their ID in this case. Okay, so that's the way what we're doing at this stage. That's the way random access files will work. There's much better ways, but that's the way they're going to work for us. Okay, so think of them like a big sparse array, where you're only filling in some entries. You have lots of blank data maybe in your array. So there's a bunch of methods. File channel open. There's a position method that tells you where you are in a file. You can change the position if you want. You can read a buffer of bytes in a file. You can get the size of the file, and you can write a buffer of bytes to the file as well. There's many others, but that's the main ones we'll look at. Okay, so we've got numbers.txt, string XYZ, convert that string to bytes, a byte array, byte buffer out, so we're using byte buffers now, not buffered readers or buffered writers, byte buffer. Out equals byte buffer.wrap. We're wrapping the data, which is our array of bytes, up into a special output buffer, byte buffer object. File channel FC equals null. So none of this code here will raise an exception. So that can all be outside the try catch block. But this is the code here that can raise the exceptions. So that's all in the try block. So try FC equals file channel, files.new byte channel, file read or write. So we're opening a file from reading and writing at the same time. We can read it or write it. FC.position 0. So we're setting the file position back, or the file pointer, the file cursor, back to the start of the file. While the byte buffer has remaining data, we're going to write data to the file channel, sc.write. Okay, out.rewind, so we're rewriting the byte buffer back to the start. fc.position22, setting position to 22, and we're writing the data again to file. Out.rewind, set position to 12, and then write the data again. Okay, so at the start of the file, we're going to have XYZ. At position 22, line 22, if you like, at the file, whatever. We're going to have XYZ or round about there, and round about line 12 or 12 plus 0, maybe line 13, so it might be line 23. Everything starts at 0. we're going to have the XYZ as well. So we're going to have a file with XYZ at the start, and then a big gap, and then XYZ, and then a big gap, and then XYZ. Okay, so here we're setting the position, but we could also be using the employee ID or some other field to set the position in the file. Okay, and how much space is allocated depends on how big you set the position. So here we are going to 22, so we'll have 23 lines in our file. 0 is the first line. Okay, so 23 lines in our file. But if we set the position to this number, we'd have quite a big file. Especially if we set the position to that file, the location, and wrote it, then we'd have a big file. So that's a quick look at writing out data to a random access file. We're just doing writes here. We're not doing reads. Okay. So let's now also add a reads into the equation. So to access a particular record, we set the file position or file channel position to n-1 because arrays start at 0 in the file. So record 0 is the first record. So 0 minus 1 or n's the number of records, so n-1 times 50. So here we're assuming or setting each record to be 50 characters long. Okay. So for what we're doing at this stage anyway, you kind of have to know how long your records are and make them all the same length. Okay, so there's kind of that drawback there for now. Okay, so that's setting the position. The record number, -1, because 0 is the first record, times 50. We're assuming 50 characters per record. Okay. So when we do that sort of thing, we can say to the user, enter the employee ID. There's our string. We're writing out to the file. Rec size is s.length, so we're getting the size of the field. So that's a general employee. So we're assuming their name is that long. That's their employee ID. That's their salary, and their name is whatever that many characters is. It might be 10 characters or something. Okay, and we're setting the record size to s.length. So that's a general purpose record. If you set it to so the record length is accounts for names of length 20, and you have someone that starts got a name length of 50. Then guess what? You're going to go through and read all your records as 20 and write them all out as 50 or whatever, plus add on the employee ID and the whatever salary and whatever other fields. So you've got a lot of jumbling to do if you need to add longer names in later. So it's probably best to choose a long length for the record length, but you don't want to go too long because it's wasting space. And if you've got big gaps between employees, there's going to be lots of blank data in the file. Okay, so getting an employee ID from the user, ID equals integer.parseString, whatever they typed in, ID strings, the next line of input. Enter name for employee ID, whatever, get the name. So name equals input.next line. Enter the pay rate, get the pay rate. S equals ID string plus the delimiter, plus the name, plus the delimiter, plus the pay rate. So all that's fine to do. We're not ensuring that these 4 characters here are if the record's 50 characters long, we're not ensuring they're the last 4 characters. We're just hoping that they don't enter a name that's longer than that makes this blow out beyond that. So a name's not longer than that. Whatever the number of characters there is, 10 characters, 20 characters, whatever that is. We're hoping they don't enter something that's longer than that because that's our record size. So really down here, we should be saying if name is longer than whatever that size there is, we should be displaying an error and asking for another name. We should be looping. But, we're just assuming everything's okay here. fc.write the buffer. So we're setting a position in the buffer, ID times rec size. So it's the employee ID 10, then we're jumping down to location 500 in the file or whatever. If rec size is 50, whatever. And then we're writing the buffer at that location. Okay, so end up with a great big sparse file like this. Okay. Depending on what ID you entered, if you enter a small ID like that, then you'll only be so many records in the top. If you enter a long ID, you'll be that number times the record size bytes down into the file. Okay. And keep looping while the user keeps entering an ID that's not quit. So that's writing data to a random access file, and you end up with a big sparse file. So on. So data like that. I've got the commas there because it's plus delimiter, and the delimiter is a comma. That's why the commas are there. But of course, we're not putting out any new lines there, so it's not going to look like that on screen. And if you drag it into TextPad, it's going to look like it's going to look like so if a rec size is 50 characters, it's going to make it so it's 50 characters long, and then there's going to be Frankie followed by enough data to fill up 50 characters. There'll be multiple lines of data there, so there'll be Frankie be way off the screen over there, and this chap here would be at the other side of Singapore somewhere. If I scroll off the screen. So, a big sparse files you end up with for what we're doing so far. You can process a random access file either sequentially or randomly. So you can read the files in sequentially if you want and process them, or you can read them randomly. Read employee sequentially application reads through 1,000 random employees.txt file in a for loop. When ID number is no 0, no entered records are stored at that point. So the application doesn't bother to print, just the way this current things are set up. No employee ID 0. To display records in order based on a key field, you do not need to create a random access file and waste unneeded storage. Here we're wasting unneeded storage, filling everything up with bytes and lots of blanks. By using a random access file, you retrieve specific records in the file directly without reading through other records. So you just jump to a location and start reading. They're very fast. Okay, so here we're asking the user to enter an employee ID. ID equals integer.parse the ID string. Buffer equals byte buffer.wrap data. Data is our array of bytes, which gives us our length there. That's our data. And then we're jumping to that position in the file, ID times rec size. So that's our rec size is the size of that string as well. Our template for an employee record, getting the size of that and jumping to that ID times rec size in the file. So they enter 5 is the ID. We'll jump to 5 times whatever that is, 5 times 50 or whatever that size is, 250. And then we'll start reading from that point onwards, position 250 in the file. Then we'll read the buffer. It's going to read as much data to fill up the data array, which is according to our size. So if our rec size is 50 characters, it's going to read 50 characters of data. fc.read buffer. And then we can convert that data into, convert it to a string, and then display it to the user. So it's coming in as comma separated data. So we could do a string.split on it and convert it out into employee ID, name, and pay rate as well if we wanted to. Okay. So jump to the location in the file based on the ID or whatever. and read a buffer full of data, which is your record size. So the best way for us to do that at this stage is to have a template record like this one, and base all your record sizes on that one. And make it so it's big enough to fit any reasonable names or whatever, any data you need to store, addresses and whatever. Make it so it's big enough, but don't make it massively huge, because it just makes your file massive as well and sparse. Okay, so if you leave 1,000 bytes for address and no record goes over 100 bytes for address, then you're going to be wasting 900 bytes per record of storage. Okay, so the file on disk is still huge, but it's very fast to access. And that's about all we do on random access files. There's a whole lot more we could do. That all of these topics are huge iceberg topics. That's about all we do. So if you get time, have a go of it. We definitely do a lot of file I/O on a follow-on course. So have a play around with it. Even just a sequential reading and writing of a file. That would be great if you could do an example on that. Okay, that's probably all we got time for in the for the lecture anyway. That's all we got for our lecture. Are there any questions on anything we've done for the lecture so far? Sequential files, reading, writing, random access files, reading, writing. I'd suggest these are all in the text files that are provided on the course webpage. So I recommend you grab those examples and run them, and then you can see what's really happening. Okay. And type in a value of 999 for the employee ID and watch the file grow. Okay. No questions? Okay. So what we might do then is have a look at some assignment 2 related stuff. And for that, I'll probably go back to the dog and dogs classes, because they're things I can talk about without working directly on the assignment. Okay, so I'll copy those here. So, and the way the assignment's set up, the dogs and the dog tester are all in the one file. Okay, which is fine. That's fine. So just to refresh your memory on these. So dog was the data for a single dog. So we had dog name, dog age, dog, some default constructor, parameterized constructor, get dog name, get dog age, the toString method, set dog name, set dog age. So that was our dog class that could handle data for one dog. And then we had the dogs class, which had an array list in it. Okay, and we had to say when you call the default constructor, it just created some test data, new dogs. And a get dog, or a get, and you could pass through a dog name, and it would do a search for that dog name. And if it found the dog name in the array list, it would return that index location, so you could return the data for that dog. So you could do a search on Fido, for example. And display dogs just displayed all the dogs in the array list. And then we had some mutated methods: add a dog, added the name and dog and a dog name and dog age, created a new dog, added that to the array list. Had sort as well, just a sorting. Remove a dog, we added that as well. So we did a search, and if the index was greater than or equal to 0, then we found a match, then we did a remove. Remember all this code? We talked about this in a couple of weeks. We talked about all this code. And then we had the user interface, which is the dogs tester. Okay. Now in assignment 2, this class and this class are combined together into the GUI. Okay, which is fine. So it just means you've got one extra class to worry about, and that's your data class. Okay. So let's change things slightly. So we'll get rid of our data class. We'll get rid of dogs. Sorry, and we'll just have the dog tester and an array. Okay, so let's add an array in. So dog. Size constant, final int max size equals, I don't know, 20. And I won't create a GUI for this because we don't have time, but I'll just show you how things work with the array. Okay, so I'll get rid of all this code, or I'll comment it out for now. Just so it's still there if you want to reference it. And I'll put all this stuff up top. So now we're doing dogs. So if the user types in a dog into the GUI fields or into user input into a scanner object, we want to create a dogs object, we could do that. So dog kb.next line. That would give us the name they typed in, and integer.parseInt kb.next line. So if the user entered the name and then the age of the dog, enter the name, hit enter, enter the age, hit enter, then we could convert that to a dog object using just the kb next lines to get the data and then convert it to an integer when we need to. Is that okay so far? So I'm assuming they've got all the codes here. But you understand that? And getting the setting up a dog from the user input. We still got 8 people.
Yep, we do still have 8 people.
Yes. Do you understand that, Sanjin? Is this code? Do you understand this? Is this okay?
Not quite. May I have a look at the code for the dog.java to make sure that.
So I'm just calling that constructor.
Okay. Okay.
Just a very simple data class, like your pizza class is. It's a very simple data class. Okay. So we're creating a dog. If we're getting this data from GUI components, it would be slightly different. It would be name text field get text. This would be age text field get text. Okay, so this is getting the data from the GUI components. This is getting it from user inputs, assuming KB is a scanner object and you've prompted them for input. Okay, same sort of thing. So once you created a dog object, you need to see, need to add it into our array. Okay, so we want a int numDogs or current dog or whatever, current dog equals -1 or 0, say current dog 0, or -1, current dog index, I'll call it, just so there's no confusion about whether it's an index or not. Okay. Current dog index, if current dog index is less than max size -1, because we're dealing with index, not array sizes, then we can add the data to the array. Or if you want to do it the other way, if you want to do an error message, if current dog is greater than or equal to, then we cannot. So we're going to go system.out.println error. Okay. We're creating a dog either from scanner inputs or from console or from GUI component inputs. So the text fields, we're getting the data out of the text fields, converting it to text or integer and text, and we're passing that text or that string and that integer through to our dog constructor. So we're creating a dog. And then we're seeing if we can fit it in our array. And if current dog is greater than or equal to max size -1, then we don't have room in our array. We've exceeded our array size. Else, current dog index ++. So now if we do this for the first dog, current dog index is now 0 because we set it to the -1 up here. Okay, so for the very first dog, the index will be 0, which is the start of the array, which is perfect. So we can add that dog in. So dogs, square brackets, dogs index equals doggy. Okay. If you want to clarify things slightly, I'll call this new dog. New dog. So the dog we just created. Okay. So this is checking whether we can add a new dog into our array. Okay, and if we can, we're incrementing the index and adding the dog in. So dog's current dog index equals new dog. So whatever that object there is, that's our value of that current array element. And if we want to display all dogs, we could say for int k is less than something ++ system.out.println dogs square brackets k, and it's just going to call that toString method. So we can say .toString on that if we wanted to, just make it a bit clearer. .toString. So what do we need to put here? Should it be max size or should it be something else? And should that be a less than or should that be something else? Let's put max size for now and we'll see what happens. And I don't have those text fields, so I'm just going to hard code the data for now. So really before you create the dog, you want to check if your array size has been exceeded as well. So maybe you want to do that down here. So you want to check your array size first, and if that's an error, display an error. There's no point proceeding with getting the user inputs. We've exceeded our array size. Okay, and of course you want to do your validations here. If the name's blank, else. If this is a problem, else. If the age is less than 0, else. So do all your validations as well. But eventually you end up with valid data, and that's when we're creating a dog. Now I'm going to assume new dog equals Frankie 6. So create a new dog called Frankie, increment the index, and add him at that location in the array. And then I want to display all dogs. So control 1. It's a shame Java doesn't understand my shortcuts. Okay, print line. Some of those there. Dog index. So we're dealing with a static method here, so we'll make our data static. Static final. System out print line again. So dog name is Frankie and the dog's age is 6. And then we're getting a null pointer exception. Okay, so Andrew said dogs.length. We'll have a look at that in a sec. So what's happening here? We've only added one dog into our array. There it is there. That's the only dog we've added. but we're trying to look through all dogs, and we're trying to call the toString method for dogs that are null. Okay, so by default, this is reference data. So by default, this array is full of nulls, and it's only when you say equals new dog and store that in the array that the data is stored in the array for a dog. Okay, so it's working for the first dog, Frankie, but all the other dogs are null, so we're getting that null pointer exception. So maybe we could say, Andrew suggested dog.length, but isn't that just the same as size, max size? It'll be dogs.length, the array name.length. Okay, that's the same as max size, so that's no good either. Current dog index, perfect. Current dog index. And should it be less than current dog index or less than or equal to? Because our current dog index is always pointing at the last dog. Here it's 0 because it starts at -1. Depends what you start at. Okay. Here I'm starting at -1. In your assignment, you might start at 0, in which case current dog index is pointing after the last dog. Okay, so all depends on what you initialize it to and when you do the incrementing. So less than current dog index will give us the dogs up to, but excluding the current one. So if we've got one dog in our array, we get all dogs up to it, excluding the first one, which is no dogs. So we want to make that a less than or equal to in this case. Okay, so control 1, control 2, and there's Frankie. Okay, let's assume we've done this input multiple times and added multiple dogs into our array. I'll just hard code the mechanism for now. New dog Bella, she's 7. Okay, so I've created another new dog. I've incremented the index, and I've stored that new dog at that location in the array. So assuming we've clicked the add button twice. Okay, so I'm just doing it like a cut down version of the add button. Control 1. We created a new dog twice, that's all. So we've got it there and there, so we can't create it again from scratch. So we'll just reinitialize it. And then you'll see there's Bella and Frankie. Okay, so we're just incrementing the index and storing that dog that we just created at that location in the array. Okay, yeah, no, so we've got a question there. Will this be uploaded like all the other lessons? Yes, absolutely. I'll upload it as well. Yeah, for sure. Okay. So don't get distracted by the whole problem for the assignment because it's paralyzing. Okay, just try and focus on one little bit. Just try and get the add button working. So you want to check your array size, because if the array size is already blown, there's no point prompting the user or validating data. Else if check the age, else if check the dog name, else if check this, else if check that, else, and that's when you want to run this code to create a new dog and add it into the array. Okay, so that's when your data's all valid. Okay, just think back to those examples we did. And then displaying a doggy. We're displaying all dogs in the array list. Okay. And if you had a heading line as well, you could call display headings and whatever before the loop, and then just display the dogs in the thing. Okay. If you wanted to do a search, well, I'll add a few more doggies first, and then we'll do a search. And we'll add in Samuel, or Seminole, and he's about 9. And we'll add in Winnie. She's about 9 as well. We don't really know because they're all rescues. Okay, so now we're adding in Seminole, Teeny, Bella, and Frankie. So I'm adding in 4 dogs to the array list. Let's just make sure that still works. And there they all are, all the doggies. So if I want to display the data in a nice tabular format, all I need to do is change my toString method here. Okay, let's do that. Instead of doing it return like that, we'll do return, and we'll use string.format, %s, and I want a dog name that's say 15 characters wide, and I want it left justified. That format's a dog name. And then we'll do the age. %D for decimal. 4 digits, age, just to leave a bit of space between the columns as well. That'll do. So we've changed it so instead of getting all that texted as well, we're getting a nice rows and columns of data. So each doggy data will be in a column. Put a bit of a space between it as well. Just for fun. Compiled. Let's compile and run this. And see, now we're getting our data in a nice table. Okay, so just by changing one method, the toString method, we can make sure our data comes out in a nice table. Now your assignment says when you add a dog to the array list, when you add a dog to the array displayed in the text area. So instead of doing system out print lines, we'll be going my text area or whatever it's called dot append dogs.toString or something like that. Okay, set text or toString or append. So set text or append you'll be using for your text area. Okay. So it's probably not a bad idea. Well, yeah, whatever, it doesn't really matter. So if you want to just display the current doggy up here, pretending we'd say dogs current index .toString, or if you want to display them in a text area, it'll be my text area .set text dogs current dog string toString. Okay, I don't have the text area, so I'll leave that out. But that's going to display the current dog. Okay, so I'll put that message out to the screen just so we can make that really clear. I'll just make Frankie the last one because that's we're just simulating clicking the add button. Okay, so this would be one ad, and I'm just adding these other ones just so it gets more data there. Okay, so just simulating adding the add button a bunch more times, just shorthand. Okay, so let's do that, and then you see there's a new dog, Frankie, and then we're displaying him in the loop. Okay, so when you're assignment, you click the add button. You do the validations, you check if there's space in your array, you do the validations, and then you create a new pizza object and you add it into your array and then you display the array. So it's going to be some sort of code like this. You might want to call the set headings as well to get the headings there. So maybe it's going to be an append. Maybe you can have your display headings. Which doesn't append with the headings or whatever. Okay, so that's the sort of code you'll have in your assignment. So, okay, does that help? So this would be for the add button. Check your array size hasn't been blown, and then do your validations, and then everything's valid. Then that's when you create the new dog based on the user inputs. So that get the text field data and convert it to integers if you need to. Add one to index. Store a pizza at that location, and then use these sorts of commands, display headings and my text area.append to display the pizza to the text area. Okay. So when you're doing a search now, let's do a search. Let's pretend we're doing a search. So I'm going to search for we'll just search on Seminole. So we want to loop through all dogs in the array that are currently there. Again, you don't want to loop through max size or the length of the array, because then you'll be comparing nulls, which is going to crash your program. And if that dog dot get name, I'm just getting the dog name, which is our getter over here, accessor method, get dog name, dot compare to. I'm going to make mine case insensitive, ignore case. If that equals the search name, if that's true, then we can display that dog to the screen or append them to the text area or whatever you're doing. Okay, so now we're doing a search, system out print line search. So something like that. Oh, sorry, not equals true, equals 0. Yep. Control 2. So you can see there I've done a searching for Samuel and I found him. Okay. And if there were multiple Seminoles in there, we'd find them all. Maybe you want to keep a track of search counts. So int count found count is equal to 0. Maybe you want to do that, found count 0. And then you could say found count plus plus. And at the end of the search loop, if found count is still equal to 0, then you didn't find any matches. And you could say something like that. So if found count's still 0 after the loop, then you haven't found a match, so you could display an error saying that name wasn't found. Okay, so let's do a search for search for Banjo instead of Seminole, because he's not in the array. You'll see Banjo wasn't found. Does that help, Trent? Does that and Sanjin, does that help you guys? Anything else you want to have a look at before?
To be honest, I'm not really sure.
Okay. Okay, can you be more specific? Can you give me any questions or specific areas to?
No, I just feel like I didn't really understand the code for searching.
Oh, for searching? Okay. So here we're looping through the array, all the items in the array. Okay. And we're getting the dog name at each location in the array. So get dog name. So dog's K is a dog, like Frankie and so on. And we're getting the dog name. And we're comparing to the ignore case the search name. Search name is Seminole or Banjo, whatever we're searching for. And if that returns,
okay, so it's like loop, just bringing a dog, look at the name, bring different dog,
exactly
look at the
right.
name.
Exactly right. Yep. Mm-hmm. And if compared to return 0, then we found a match. Okay. Okay. And so we found a match, so I'm displaying it to the screen, but in your assignment, you're probably going to append it to a text area and then add 1 to a found count. And then if the found wasn't, if nothing was found, you're probably going to display a dialog saying, so yeah, so good point from Callum. Just reading there, so, okay, so I'm getting a message here saying I'm happy with that so far. I should be able to go a lot further. If you've got any more questions, ask on Friday. Yeah, we'll go through it on Friday for sure. Come along with specific questions and we'll we'll get stuck at it on Friday. I can't show you on the assignment, but I can certainly show you on the dog class. Okay. So Callum's made a good point. Does this work the same? And it does. Okay, so if you want to avoid having to do that line of code there, you can just do this. So I'll comment at the old stuff and I'll show you the new way. Equals new dog. So you can do it with 3 lines of code where you create your dog and then add one to the index and then store the dog in the array, or just add it straight to the array. That's fine as well. Okay, so both of those are the same. Okay, that's good. Any other questions before we finish off? Okay, so we'll work on your assignments and we'll talk about it more on Friday. And any specific questions you got, please bring them along and we'll tackle them and see what we can do. Okay. Okay, thanks everyone for coming along. We've still got 8 people here, so everyone made it to the end, which is great. So thanks for coming and I'll see you on Friday. Have a nice time. Bye-bye.